The James Webb Telescope has made an unexpected discovery. City lights in space, 7 trillion miles away from Earth. This exceptional finding has ignited interest in the chance of extraterrestrial life. The telescope zeroed in on Proxima Centauri B, the nearest exoplanet to Earth, uncovering strange, splendid lights exuding from it. What could be the reason for these city lights on Proxima Centauri B? Might this at some point show the presence of life past our planet? Come along with us as we investigate how these extraordinary space objects were discovered by the James Webb Telescope. Humanity and scientists have eagerly researched and awaited the discovery of life beyond our solar system for years. Any proof that upholds this space dream has been greeted wholeheartedly. As of late, mainstream researchers were stunned by strong proof of living things existing in space, as seen by the James Webb Space Telescope. While investigating in space and detailing fundamental data back to Earth, the telescope saw weird city-like lights sparkling from Proxima Centauri B, a close-by exoplanet. The resemblance of these lights to those of a distant city sparked speculation about the existence of an extraterrestrial civilization on the exoplanet. Scientists have been in awe of the finding because it appears as though the existence they had been searching for may have been found. Assuming this ends up being valid, it would imply that astute living things could be sorting out civilizations obscure to us in space. The inquiry that emerges is how long have these lights been sparkling in space, trusting that humankind will foster the innovation to identify them. David Kipping, a cosmologist from Columbia College, depicts Proxima B as interesting because of its shifting warming examples, which are not normal for those of different planets. Proxima B's infrared nature differs significantly from that of its host star, Proxima Centauri, in comparison to the majority of rocky planets, which both absorb sunlight and produce infrared radiation. This made it an ideal contender for the James Webb Space Telescope to notice. The unique heat signatures of Proxima B that the telescope has been able to detect due to its infrared sensitivity may hold the key to understanding the universal secrets of its atmosphere. Researchers intend to utilize the telescope to examine Proxima B's climate and evaluate the conceivable outcomes of human home. The James Webb Space Telescope is especially fit to this undertaking because of its capacity to identify faint light beams in the vast dimness, making it the ideal device to affirm the presence of city lights on Proxima B's night side. As long as it falls within a particular frequency band, the telescope is able to detect any artificial illumination in the universe. Similar to Earth, Proxima B has day and night cycles with solar heat during the day and cooler temperatures at night. The planet's temperature vacillations are affected by its air arrangement or scarcity in that department. On the off chance that Proxima B misses the mark on air, the temperature distinction among constantly would be outrageous, with the day side turning out to be singing and the night side freezing. The James Webb Space Telescope's high-level infrared imaging capacities permit researchers to concentrate on Proxima B's warm emanations and environmental properties. Strangely, the telescope's circle around Earth lines up with Proxima B's orbital period, permitting total perceptions of its day-in and day-out cycles inside 11.2 Earth days. In the event that an environment is without a doubt present, the following stage will be to concentrate on its compound structure to decide whether it could uphold life. Oxygen, water vapor, and methane are gaseous indicators of habitability. Be that as it may, deciding the presence of these gases requires fastidious perception, as researchers should catch and inspect light beams going through the planet's environment. The James Webb Telescope is great at analyzing concentrations of methane, carbon dioxide, and water vapor, but it is not very good at identifying oxygen, which is a crucial sign of life. Notwithstanding these constraints, the telescope can in any case look for ozone, which gives bits of knowledge into the planet's air and potential forever. The James Webb Space Telescope's observational reach is restricted to a couple of neighboring tenable universes, provoking stargazers to go to ground-based observatories like the Very Huge Telescope ELT, as most would consider to be normal to start activity in 2028. The ELT will provide more in-depth insights into the atmospheric structures of far-off exoplanets and, potentially, more complete information regarding their habitability. The James Webb Telescope continues to play a crucial role in our quest to decipher the mysteries of distant exoplanets, while we await the deployment of subsequent telescopes. It has the potential to revolutionize our understanding of exoplanetary exploration despite its limitations. Researchers are planning to lessen the brilliance from a planet's host star to more readily concentrate on light reflected from the planet, utilizing techniques like inside veils or outer satellites to shut out the star's beams. This approach will permit future telescopes to study far-off exoplanets all the more strikingly, assisting cosmologists with separating between gases created by life and those delivered by geographical cycles, like volcanic movement. Scientists continue to push forward in their search for evidence of life beyond Earth, despite the difficulties they face. The James Webb Space Telescope offers a brief look at logical headways in exoplanet research, indicating the astonishing revelations yet to be made. As we extend our comprehension and investigation of the universe, we are better situated to get a handle on the universe's mind-boggling operations and our job inside it. Indeed, even following quite a while of looking, no planet has been conclusively found to have life. However, the journey for life past Earth proceeds. For a long period of time, mankind has contemplated whether we are distant from everyone else in the universe. The James Webb Telescope is still used by scientists to look for alien civilizations and look for signs of life on planets. A famous story has arisen as of late, recommending that outsiders may be out there, hanging tight for us to track down them. To investigate this chance, American cosmologists Jill Tarter and Thomas Pearson established the SETI Foundation in 1984, a not-for-profit adventure devoted to filtering through enormous transmissions to distinguish radio transmissions from space. Radio signals are thought to be ideal for extraterrestrial communication because they can travel a great distance without scattering or being absorbed. Albeit the SETI establishment presently can't seem to recognize outsider radio transmissions, Jill Tarter remaining parts hopeful, accepting that cutting-edge instruments will speed up the quest for enormous friendship. As of late, NASA detailed that the James Webb Telescope had identified city lights on Proxima B, adding to the fervor encompassing the quest for extraterrestrial life. The most important instrument that humans have for comprehending the universe is the James Webb Space Telescope. It is currently orbiting 1 million miles from Earth, capturing elusive information about the formation of galaxies, stars, and planets and providing invaluable insights into the early stages of the universe. Specialists are utilizing the telescope's state-of-the-art innovation to dissect the actual properties and synthetic pieces of divine bodies, including exoplanets. By disconnecting explicit frequencies of light, the James Webb Telescope is uncovering crucial hints about the airs of far-off planets, possibly uncovering faint hints of life. With its unmatched capacity to concentrate on existence, the telescope is ready to make pivotal disclosures about the universe. One such disclosure is the presence of more mass in the universe than recently suspected, concealed inside Goliath systems and testing early models of the universe. The James Webb Space Telescope keeps on reporting new data about disengaged universes, adding to mankind's continuous investigation of the farthest reaches of room. Over 4,000 exoplanets orbiting distant stars have been found by astronomers. But this is just the beginning. There are reasonable trillions of unseen exoplanets dispersed across the universe. In spite of the difficulties, not set in stone to track down outsider territories, utilizing each device available to them. A long time back, the domain outside our planetary group was scarcely investigated. However, today, stargazers are uncovering new planets at an uncommon rate. The search continues, fueled by discoveries like Galileo's spacecraft, which unintentionally revealed spectral signatures suggesting extraterrestrial vegetation on Jupiter, despite the fact that no definitive signs of life have been found. The James Webb Space Telescope is supposed to reveal a greater amount of these biomarks. For example, the vegetation red edge, which could assist with distinguishing life by dissecting how it mirrors light. By using this method, scientists will be able to map the orbital parameters of planets that are habitable, which will provide crucial evidence for the search for intelligent life beyond Earth. Using the telescope's advanced spectroscopic capabilities, the spectral pattern produced by sunlight passing through a planet's atmosphere can be analyzed. Based on this information, it may be possible to discover the atmospheric compositions of planets that are similar to Earth with the help of the James Webb Telescope. Life may exist on planets with atmospheres rich in carbon dioxide, nitrogen, and oxygen. The shortfall of strange mixtures could highlight elective types of life and, surprisingly, innovative civilizations. Counterfeit atoms like CFCs, which are created by modern cycles, could be recognized on far-off exoplanets, giving unquestionable verification of extraterrestrial movement. The disclosure of such particles would open another outskirts for analysts, permitting them to concentrate on outsider developments past the smooth way. Life past Earth might take structures we've yet to envision, rising above the natural restrictions we know. In the end, the James Webb Space Telescope is a crucial tool in our quest for knowledge and the drive behind our search for life elsewhere on Earth. The secrets of the universe are ready to be opened, and with the assistance of cutting-edge space telescopes, we may before long find that we are in good company.